Hello friends, today we are going to solve a problem in physics, a kicked football problem. A football is kicked at an angle of theta equals 37 degrees with a velocity of 20 meters per second. Calculate its maximum height, this height here, the time of travel before the ball hits the ground. How far away it hits the ground, we mean this distance here. The velocity vector at the maximum height and the acceleration vector at maximum height. Assume the ball leaves the foot at ground level and ignore air resistance. Now let's start with our solution. First of all, we take the y direction as positive upward. The components of the initial velocity are Vx naught equals V naught cosine 37, which is 20 multiplied by 0.799, which gives 16 meters per second. And Vy naught, the other component, is V naught times sine 37, which is 20 multiplied by 0.602, which gives 12 meters per second. Now, at the maximum height here, the velocity is horizontal, which is Vx naught equals 16 meters per second, as air resistance is ignored. And this occurs at time t equals Vy naught over g, which is 12 over 9.8, which gives 1.22 seconds. This is the time taken to reach at this point here. Now we can find the maximum height using the equation y equals Vy naught times t minus 1 over 2 gt squared, which is 12 times 1.22 minus 1 over 2 times 9.80 multiplied by 1.22 squared, which gives 7.35 meters. This is its maximum height, 7.35 meters. Now, to find the time it takes for the ball to return to the ground, we shall substitute y equals 0 in the same equation. That is, 0 equals 12 times t minus 1 over 2 times 9.80 times t squared. This is a quadratic equation which can be easily solved, and we get two solutions, t equals 0 and t equals 2.45 seconds. Now the first solution is ignored because it corresponds with our starting point, so the solution we want is the second one, 2.45 seconds. Now the total distance in the x direction is x equals Vx naught times t. This is a uniform motion in the x direction, so this is 16 times 2.45, which gives 39.2 meters. This is the distance. Now finally, the acceleration vector at the highest point is g, which equals 9.80 meters per second squared. Thank you for watching this video.